Another part of our activity in environmental monitoring is in the marine domain, and we've done quite a bit of work in creating some very novel underwater robotic systems. And I think what really sets them apart is their use of computer vision in order to navigate underwater, where of course there's no GPS signal. So a couple of the robots are shown here. This is the first generation one, and you can see another picture of it here. And this particular configuration of the robot was some experiments we were doing trying to see if this robot could be effective in injecting Crown of Thorns starfish to control their runaway population growth, which is endangering the Great Barrier Reef. So this is first generation underwater robot. More recent version is seen here. It's quite a sophisticated design, much easier to put into the water. It's just got a simple handle, put it over the side of the boat and drop it in. It's got a pair of cameras underneath, so it can see how high it is above the seabed and how it's moving. Another pair of cameras in the front, so it can look out for obstacles and swim safely under the water. Another part of our activity, again, is outreach and competitions. And so QT have entered an international competition called the Maritime Robotics Challenge, I think 3 times now, and it's been held at various locations around the world. And we've come variously 3rd and 2nd in those competitions. And the competition is basically taking a rigid inflatable boat, fitting it out with a whole bunch of sensors and computers, and it has to navigate a course in a harbour and do quite complicated missions. Another part of this marine activity is autonomous boats. So these are robots that float around on the surface of a body of water. And a particular application we've been looking at is using these to monitor water storages, drinking water storages, looking for things like toxic algal outbreaks, and also looking for methane emissions from some of these larger water storages.